All right, guys, so this is going to be the first example of how to solve a system of equations. I mentioned system of equations the other day when we were doing the Function Friday assignment. Um, a system of equations is really just multiple equations, a set of multiple equations, but they have the same variables. So in this case, x and y are in both equations. So what I'm looking for a solution to this system is an x and a y value that would solve both equations, an x value and a y value that would give me a true statement for both equations. So basically when I'm doing it on a graph, there's multiple ways to solve these, but we're going to start out with the graphing method. So I'm going to start out with my top equation where I know m is equal to 2 and b is equal to 4. That's in slope-intercept form. So it should be easy to graph. All I have to do, start out at my y-intercept. And then if my slope is 2, I'd want to go up 2 and over 1. Now that would put me probably right around, well, let me make that neater. Probably right around there somewhere, but I'm going off the graph. So rather than go off the graph, I can also reverse the slope. Rather than going up 2 and right 1, I can go down 2 and left 1. And then down 2, left 1 again. Down 2, left 1, and just keep going. That one's a little off. 2 and left 1. Right there. And right here. So I end up with a line. Wasn't the neatest, but it looks something like that. And then I can go on to my next line, which I can see is also in slope-intercept form and has a slope of 1/3 and a y-intercept of -1. B equals -1. So I can start at my y-intercept. And if my slope is 1/3, that would mean go up 1, right 3, up 1, right 3. I'd go off the graph again, somewhere around here. So again, I can reverse the slope. Rather than going up 1 and right 3, I can go down 1 and left 3, which would put me right here. And you notice that these two lines, sloppy again, I'm sorry, but these two lines, they intersect right here. So that point right there is -3, -2. That's where these two lines intersect. That is the solution to this system of equations. That means if I plug in -3 for my x and -2 for my y value, if I plug those into these equations, I should get a true statement. So I'll show you for the first one, y equals 2x plus 4. If I plug in -2 for y and -3 for x, and now I'm just checking to see if I get a true solution. I'm checking to see if this gives me a true statement. So I'd have -2 equals -6 plus 4. And -6 plus 4 does equal -2. So I got -2 equals -2. That checks out. So since that gives me a true statement, I know -3, 2, or -3, -2 is a solution to that equation. I also have to check if it works for the other equation. So if I plug it into the other equation right here, that would be -2 equals 1/3 of -3 minus 1. Well, 1/3 of -3 would be a -1. So on the right side, I have -1 minus 1. -1 minus 1 is -2. So again, I get a true statement. That is a solution to both equations.